number 3, we were asked to find, we were asked a ladder 25 feet long is leaning against the wall. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when its base is 7 feet from the wall, 15 feet, 24 feet? What happens to the speed of the top of the ladder as the base approaches 25 feet from the wall? Now, we start off by writing a simple little triangle. Now when it starts off, A will be equal to C because B equals 0 because the ladder is next to the wall, parallel. So then we figure out our knowns and our initials. We know C equals 25 feet. We know V1 equals 2 feet per second. We know B equals V1 times time, or B over T equals V1. So we get the equation T equals B over V1. And we know our initials. A initial equals 25, explained by the picture. B initial equals 0. T initial equals 0. Now, we also know Pythagorean theorem holds true because it's a right triangle against the picture. So then we said, say, C squared equals A squared plus B squared. Now we know V2, which is the velocity that the ladder is being pushed down, is delta A over delta T, or A final minus A initial over T final minus T initial. Now plugging in everything we know from initials and known numbers given, we know that this A final equals the square root of 25 squared minus B squared. So we plug in A final in there. A initial is 25. And we know that T final will be B over 2. And then we get to the equation V2 equals 2 times the square root of 25 squared minus B squared minus 50 all over B. For the part A, we were asked, what if B equals 7 feet? What would the velocity be of the ladder being pushed down? V2 equals, plug in 7 for B, and we get negative 2 over 7 feet per second. Go.
For the second question, we're asked when B equals 15 feet. We'll just plug in B here and here, and we will get that to be, the ladder is going to be going down at negative 2/3 feet per second. For C, when B is 24 feet, again, we just plug it in here. We get it equals to negative 3/2 feet per second. And when B is on the ground, we can take the limit of that and plug in B equals 25, and we will get that B is going down at a negative 2 feet per second.